Our next topic is percent composition. As I look back as to how I learned these things, I'm always struck by the fact that I look back to actual experimental procedures that I had to perform that drove this deep into my brain. And in terms of percent composition, anytime as a graduate student or as a research scientist, I made a substance that I had to verify the composition of, especially in the old days, I would have to send it out to a lab to verify its percent composition. If it was not within, I don't know what it was, 0.3% of what it was theoretically determined to be, I had to purify it again and send them another sample. They didn't know what it was. I knew what it was, but I couldn't tell them. And so if it was a match, we had a very good evidence that at least the molecular formula, or actually the empirical formula, would be correct. I hope that makes some sort of sense. We're talking about percent composition, and let's do it by example. It is the mass percent of each element in a substance, and the key to this really is to assume that you have 1 mole. Let's do water as a very simple example, but all the other ones are just analogous to this. Can you see that water is 16/18 oxygen by mass? Imagine a very large oxygen atom and 2 very small hydrogen atoms. Although it has twice as many hydrogen atoms, they're so small that they are, I think, about 10% of the total mass, right? 16/18. And that's the math that's involved. Water is clearly 16/18 oxygen by mass. The oxygen atom is much bigger and much heavier. Therefore, 16 divided by 18 is 0.89, turn into a percent. Don't bother doing the 2 divided by 18 because the rest is hydrogen, and you should get 89% oxygen, 11% hydrogen. That's all you really need to do to determine percent composition. Our next topic is empirical and molecular formulas.